The number of devices that can be put on a 20 amp arc fault breaker is determined by the National Electrical Code (NEC). According to NEC Article 210.23, a 20 amp AFCI circuit can typically handle up to 12 devices for lighting or convenience outlets. It can also handle up to 10 devices for luminaires, such as light fixtures with ballast-type loads like fluorescent or LED lights. These limits are based on using devices with a maximum load of 15 amps for lighting or convenience outlets and 18 amps for luminaires with ballast-type loads. The specific sections in the NEC that address this are Article 210.23, A1 and 210.23, A2. It is important to consider the type of load being connected to the circuit when determining the number of devices. Lighting and convenience outlets generally draw less current than luminaires with ballast-type loads. Therefore, a greater number of lighting and convenience outlets can be connected to a 20 amp AFCI circuit compared to luminaires with ballast-type loads. Always consult with a qualified electrician to determine the specific number of devices that can be safely connected to a 20 amp AFCI circuit. This is especially important if you are unsure about the load requirements of the devices or if you are dealing with heavy-duty appliances that may require a separate dedicated circuit. Here is a more detailed explanation of NEC Article 210.23, A1 and 210.23, A2. Article 210.23, titled Permissible Loads, Multiple Outlet Branch Circuits, outlines the rules for how much load can be connected to branch circuits with multiple outlets. A branch circuit is the wiring between the last overcurrent protective device, such as a circuit breaker, and the outlet. Article 210.23 covers branch circuits rated 15 and 20 amps. Article 210.23 A1 specifically addresses 15 and 20 amp branch circuits supplying lighting units, appliances, or combinations of both. It states that the total rating of any one cord and plug connected appliance shall not exceed 80% of the branch circuit ampere rating. This means that on a 20 amp circuit, a single appliance connected with a cord and plug should not draw more than 16 amps, which is 80% of 20 amps. The intent is to prevent overloading the circuit with a single high-demand appliance. Article 210.23 A2 deals with the total cord and plug connected equipment connected to a branch circuit. When fastened in place appliances are connected to a 20 amp branch circuit, the sum of all the loads shall not exceed 50% of the branch circuit ampere rating, where lighting units, cord and plug connected utilization equipment not fastened in place, or both, are also supplied. So, in summary, NEC Article 210.23 provides guidance on the permissible loads for 15 and 20 amp branch circuits. It sets limits on the rating of individual appliances and the total load connected to a circuit to prevent overloads and ensure safety. It is crucial to understand and follow these requirements when designing or modifying electrical circuits. Consider that heavy-duty appliances, such as air conditioners or refrigerators, typically require a separate dedicated circuit. This is because these appliances draw a significant amount of current and could overload a general-purpose circuit. It is important to consult with a qualified electrician to determine the specific requirements for your situation and to ensure that your electrical system is safe and code-compliant. Keep in mind that local codes and regulations may vary, so it is always recommended to check with your local building department or electrical inspector for specific requirements in your area. Furthermore, the NEC is updated regularly, so it is important to use the latest edition of the code when making electrical installations. Here are some additional considerations. Firstly, the type of wiring used in the circuit can also affect the number of devices that can be safely connected. For example, if the wiring is undersized, it may not be able to handle the full load of the circuit. Secondly, the condition of the wiring and devices can also affect the safety of the circuit. For example, if the wiring is old or damaged, it may be more likely to overheat or cause a fire. Thirdly, it is always a good idea to err on the side of caution when determining the number of devices to connect to a circuit. If you are unsure about the load requirements of the devices or the capacity of the circuit, it is best to consult with a qualified electrician. The purpose of an arc fault circuit interrupter, or AFCI, is to protect against fires caused by electrical arcs. An electrical arc is a dangerous condition that can occur when electricity jumps between two conductors. Arcs can generate a lot of heat, which can ignite nearby materials and cause a fire. AFCIs are designed to detect these arcs and quickly shut off the power to the circuit, preventing a fire from starting. AFCIs are required in many areas of the home, including bedrooms, living rooms, and dining rooms. They are also required in some appliances, such as dishwashers and washing machines. There are two types of AFCIs: branch/feeder AFCIs and combination AFCIs. Branch/feeder AFCIs protect against arcs in the branch circuit wiring. Combination AFCIs protect against arcs in both the branch circuit wiring and the cord and plug of appliances. AFCIs are an important safety device that can help to protect your home and family from fire. If you do not have AFCIs in your home, you should consider having them installed by a qualified electrician. Remember that electrical work can be dangerous. If you are not comfortable working with electricity, it is best to hire a qualified electrician to do the work for you. Always turn off the power to the circuit before working on it. Use insulated tools and wear safety glasses. Follow all local codes and regulations. In addition to the number of devices and the type of loads, several other factors can influence the safe and effective operation of a 20-amp AFCI circuit. Firstly, voltage drop. Voltage drop occurs when the voltage at the end of a circuit is lower than the voltage at the beginning of the circuit. Excessive voltage drop can cause appliances to malfunction and can also increase the risk of fire. The NEC recommends that voltage drop should not exceed 3% for branch circuits and 5% for feeders. Secondly, wire gauge. The wire gauge is the thickness of the wire. The correct wire gauge must be used for the circuit to safely carry the electrical current. If the wire gauge is too small, the wire can overheat and cause a fire. The NEC specifies the minimum wire gauge for different circuit amperages. For a 20-amp circuit, 12 American wire gauge (AUG) copper wire is typically required. Thirdly, connections. Loose or corroded connections can cause arcing and overheating. Make sure all connections are tight and clean. Use appropriate connectors for the type of wire and application. Fourthly, grounding. Proper grounding is essential for electrical safety. Grounding provides a path for fault current to flow back to the source, which helps to trip the circuit breaker and prevent electrical shock. Make sure all outlets and appliances are properly grounded. Fifthly, testing. After installing or modifying an electrical circuit, it is important to test it to make sure it is working properly. Use a multimeter or circuit tester to check the voltage, current, and continuity of the circuit. You can also use an AFCI tester to verify that the AFCI is functioning correctly. Sixthly, maintenance. Regularly inspect your electrical system for any signs of damage or wear. Replace any damaged or worn components immediately. Keep electrical panels and outlets clean and free of obstructions. Seventh, overload protection. Overload protection is provided by circuit breakers or fuses. These devices are designed to trip or blow when the circuit is overloaded, preventing damage to the wiring and appliances. Make sure the correct size circuit breaker or fuse is used for the circuit. Eighth, GFCI protection. Ground fault circuit interrupters, GFCIs, are designed to protect against electrical shock. GFCIs are required in wet locations such as bathrooms, kitchens, and outdoor areas. Ninth, surge protection. Surge protection devices, SPDs, can help protect your electronic equipment from damage caused by power surges. Power surges can be caused by lightning, utility switching, or other electrical events. 10th, labeling. Clearly label all circuit breakers and outlets to indicate what they control. This can help you avoid accidentally turning off the wrong circuit or plugging an appliance into the wrong outlet. Remember that electrical codes and regulations can vary depending on your location. Always check with your local building department or electrical inspector for specific requirements in your area. It is also important to stay up to date on the latest electrical codes and safety standards. The NEC is updated every 3 years, so it is important to use the latest edition of the code. The National Fire Protection Association (NFPA) offers a variety of resources and training programs on electrical safety. Consider taking a course on electrical safety to learn more about how to protect yourself and your property from electrical hazards. When working with electricity, always follow these safety precautions. Firstly, turn off the power. Always turn off the power to the circuit before working on it. Use a circuit tester to verify that the power is off. Secondly, use insulated tools. Use tools with insulated handles to prevent electrical shock. Thirdly, wear safety glasses. Wear safety glasses to protect your eyes from flying debris. Fourthly, avoid wet conditions. Do not work with electricity in wet conditions. Water can conduct electricity and increase the risk of electrical shock. Fifthly, do not overload circuits. Do not plug too many appliances into the same circuit. Overloading a circuit can cause it to overheat and start a fire. Sixthly, inspect cords and plugs. Regularly inspect cords and plugs for any signs of damage or wear. Replace any damaged cords or plugs immediately. Seventh, use ground fault circuit interrupters, GFCIs. Use GFCIs in wet locations to protect against electrical shock. Eighth, call a qualified electrician. If you are not comfortable working with electricity, call a qualified electrician to do the work for you. Electricity can be dangerous if not handled properly. It is important to take the necessary precautions to protect yourself and your property from electrical hazards. By following these tips, you can help to ensure that your electrical system is safe and reliable. Remember, when in doubt, consult with a qualified electrician. They can provide expert advice and assistance to ensure that your electrical system meets all applicable codes and safety standards. A qualified electrician can also help you troubleshoot any electrical problems you may be experiencing. Do not attempt to repair electrical problems yourself unless you are properly trained and qualified. Working with electricity can be dangerous, and it is always best to leave it to the professionals. To recap, the number of devices you can put on a 20 amp AFCI breaker depends on the type of devices and their load requirements. According to NEC Article 210.23, you can typically have up to 12 lighting or convenience outlets or up to 10 luminaires with ballast type loads. However, it is important to consider the specific load requirements of each device and to consult with a qualified electrician to ensure that the circuit is not overloaded. It is also important to follow all applicable codes and safety standards when working with electricity. Always turn off the power to the circuit before working on it, use insulated tools, and wear safety glasses. If you are not comfortable working with electricity, call a qualified electrician to do the work for you. Remember that electrical safety is paramount. Taking the necessary precautions can help protect yourself, your family, and your property from electrical hazards. Understanding the NEC and following its guidelines is essential for ensuring a safe and reliable electrical system.